Итак, мы продолжаем.
So we are continuing. We will listen now to Dmitry Grebenshchikov from Diasoft, and he will tell us about the migrating engineering software from Oracle to PostgreSQL. Hello, my name is Dmitry. I'm a director in the import substitution in the Diasoft company. We've been for 20 years. 28 years in this market. We are vendors and we actively support PostgreSQL and Postgres Professional. And from my observation of the last years, Postgres currently de facto in Russia has become a certain standard. And most users, database users and corporate enterprise consumers that thinking about migrating from Oracle, they are choosing Postgres and they're testing it. And 80% of those, they are migrating to Postgres. So why do they want to change the database? So sanctions, import substitutions, and, well, economic viability. I'm glad that at this conference there was a lot of specialists getting together, and accessibility of specialists, of experts, is one of the criteria that the consumers are complaining about. They think there are not enough experts. So people like you have a chance to find a job, to be in demand as a professional, and to try to work in this area. So our company, what we're doing, we've been working with import substitution for quite a lot. So we developed the base adapter tool that facilitate the migration, and those who want to do it, they can, because it's going to take a lot of resources to rewrite the applications that were originally developed from Oracle. The whole team was working on the application. No one knows how to do that. It takes a lot of time, takes a lot of money, and it's not one environment. There are 30 ecosystems, smaller one, bigger one. They're looking at one, refer to one database, and it's really hard, complex to do that. So we decided to facilitate this process, and we used the re-engineering approach. We have a database adapter that allows to emulate Oracle protocol. So the proxy server, a certain proxy server is used in all the applications that were referring to Oracle before that. 1521 port now can use our proxy. They can send query there as if they were working with Oracle, and they were getting responses as if the Oracle was working with them. So we emulate this protocol, and we can use all kind of the databases, PostgreSQL in particular, or Postgres Pro. So we can make this move quite smooth. And we can also do it at the hardware level. We can take a hardware of the Oracle server. We can install a hardware from the IBS company that has Postgres on board. We can also install our software in there, and all the applications can go on sending queries and getting responses the same way. Second part of our tool is a database migrator that is, well, actually allows to migrate, to transfer everything that was in the database, stored procedures, triggers, functions, indexes, all of that is moved, and 95% is moving automatically. Well, with the rest, you should do it manually, optimize it. If somehow it didn't convert, you need to do it yourself. But still, it saves money, it saves you a lot of time. And if we're talking about import substitution, we have three approaches in our company. If this ecosystem of 30 applications, you have an application that doesn't have any source code anymore, and your enterprise need this application, we have a platform that would allow you in a quick way, an efficient way, using a code generator to replace this application. We take application editor, so we add our attributes, and then we generate this application at our Russian engine PPM, and then the storage structure and microservices are replicated, so all smaller applications can be rewritten this way. If it's a medium-sized or a bigger solution, we have another technology legacy renovation that allows to transfer application completely. So I can tell you in more detail about that in the hallway. We can sub-repeat to move it to our Russian platform. And the third approach to the import substitution is replacing the database, actually, that we are talking about now, that the talk is dedicated to. That's how it looks. There was an application or an array of applications that worked with ARI. We are putting in something in between to work with Postgres, and our favorite one is Postgres Pro, obviously. And regularly in all our projects, we are measuring the performance, and it increases by 5%. So all this myth about Postgres working slower, that's just a myth, because the application that were written under Oracle, it took a lot of time to write by a lot of developers who were using different approaches, different tools to do that, and the practice, our practice shows that with minimal architectural renovations, for example, we had an application that has 10 selects in a row, so we just made one query out of them. We did the same with answers that were there consequentially, was 15 of them, so we grouped them in a different way, and then this part in Postgres started working many times faster. So now about the project itself, we use a ASKON company here, and we migrated their engineering soft LOOTSMAN, so more than 200 tables, procedures, representations. So we used our solution. We took their application. They already had scenarios, 104 workload scenarios. So we used our tool. We migrated it all. Then we manually, 3 developers, finished the job. We optimized all the unfinished parts. And then PostgreSQL started working 18% faster. I'm talking about this project because on average the performance is increasing by 5%, but here, because of the optimization and of the joint efforts of our developers and of their developers, we increased the performance by 18%. So here you can see the table with these 104 scenarios. At the first slide you can see the scenarios that work a little bit slower than on Oracle, and they're not so. There are just few of them, so we were looking for maximal, minimal, and average time to complete scenario. It is structured this way that many times we are measuring different kind of data. So some of them, they were measured 900 times, and then we compared time for Oracle and time for Postgres with the same configuration, with the same hardware. All the other scenarios, you can see them at this snapshot. So on average, they started working by 50%. So this coefficient of comparison between Postgres and Oracle shows you how much faster it started working under PostgreSQL, up to 52%. So in our experience shows that simple reads and simple writes work much better in Postgres. And with the complicated queries, on 80% of cases, it turns out that we don't need so complicated logic and we can rewrite it. And then this block becomes, starts performing better. And a lot of scenarios started working faster and more efficiently, almost 2 times faster than the Oracle. So what are the peculiarities of the migration from Oracle to Postgres? We can talk about that for hours. I can just tell about my experiences. These are autonomous transactions. So if you have a lot of transactions that are just getting immersed into each other, you've got transactions inside of which there is another transaction, there is a third transaction inside, and when you have this nesting doll of 5 transactions, you start having problems with the performance. And the way Postgres works, it is not oriented at transactions, so you have to emulate it, and it decreases the performance. But we tested their autonomous transaction mechanism, and it worked better. So we faced a number of challenges, but we managed to resolve it within weeks because our colleagues did a really good job. So now autonomous transactions and the later versions are working well. They're working quite successful, but still there is the decrease in performance when you have a lot of layers. Then Postgres shows 20% working slower than Oracle. Another thing that in most cases you can bypass it using architecture, you can rewrite it. Of course, if you have 5 transactions inside each other, even developers who wrote it, they didn't manage to answer why did they do that and what the thing is supposed to do actually. And the saddest thing is when at the end of all this chain of nesting dough, we get a rollback and it should all go back to where it was. So if it works well Oracle, then it would work fine at Postgres. But if there is rollback, then we might face problems. There is also decode and coalesce functions. We face certain challenges in Oracle, as it turned out. It doesn't compute. It was a construction like condition and two ways out. For example, if it says yes, then you go there. If it's no, then you go the other way. And this application worked for 15 years before that, and it never entered one of the conditions, and there it was divided by zero. In Oracle, first it calculates conditions, and then it calculates where it goes. And the branch where it didn't go, Oracle just doesn't compute it, and there was a fraction formula, and it was divided by zero. But Postgres doesn't do that, and Postgres first calculates everything, and then it checks where to go. And when it calculated, it found this error dividing by zero, and all this logic just went down. Just failed. So we had to protect from this stupid code that somehow existed for 15 years, never entering this kind of branch. So there are these kind of peculiarities. Also, Postgres is not so forgiving if we're talking about developers, coders, mistakes. And so people who work with Oracle, they write much worse code than for Postgres. So kudos to all of you, because you do much neater job, much cleaner job. So, for example, we had a problem with Oracle looking at a certain number and thought it was a complete number, and Postgres saw some fractions in there, and because of that, so calculations were different because it was calculating coefficients, and then it turned out that for many years formula had a mistake, contained a mistake. It was for 100th and thousandths, but we found it. We found this mistake, this error, and then we managed to make calculations better under Postgres. And also the query formation, creation. Postgres is much more kind to developers because Oracle first chooses all the functions and wants to put them into one plan of queries, and it works better with the optimization. But we are in touch with Postgres Pro company to find a solution, and I think in the future Postgres will learn these tricks. Postgres can see the function, it will apply the function, so it works simply, so please keep that in mind too. And a standard trick that all the projects we have in all the projects is putting all the queries into one. It increases performance manifold, so please read code carefully, try to understand what is it supposed to do. So be developers, be coders, and then your Postgres databases will work better. We have made more than 20 projects. We recommend everyone Postgres, especially Pro version. And I would like to say that we have a tool that allows to migrate faster and cheaper, and we're ready to work with individual developers, arrange things with them to give this tool to you for some social projects, education projects, for private projects, well, and for commercial use, for your unlimited use, so to say. We're ready to share it with you, share our experience with you. So please get our contacts, come to Diasoft, come to Postgres Pro company, because we share this tool with them too. And please switch to Postgres, because Postgres is a de facto standard or national champion. So, and here are some numbers for you. Postgres works with any workload, with any volumes. There are some projects in Russia and abroad. Chinese WeChat network is working with the Postgres, and all our software in company works well, and performance is really good. And with all the volumes of data, we are feeling good. And we also have complex projects, agriculture ministry. We help them to migrate from Oracle to Postgres. We have also migrated 11 servers to a new place, and the workstation to alternative workstations. We used the modern architecture. They love Docker a lot there, so we deployed a domestic mail, domestic file cloud. We have solved all the problems so they had. So we taught the users, we taught their administrators. They used Thunderbird as their mail client, and they plan to migrate everything else that is not affected by import substitution yet. I will be happy to help you too with the migration of engineering software, business software, any other kind of software that you might have. Our tool is not the same as or PG. It doesn't migrate the stored code. Our tool can process this code, and it has nothing to do with this thing. They are trying to do the same, but we've been working on our tool for 5 years with a team of developers, and we also emulate Oracle Protocol apart from migrating, transferring everything from those databases. And we have an extension on C++, like 100 lines of code. Sometimes it can do miracles, so it can resolve a lot of problems. So we added some things to facilitate the migration from Oracle, and we're ready to work with developers, with companies, with consumers, with the other developers. We're ready to share our experience. Probably that's all I wanted to tell you. I will be happy to answer your questions. That's a slide with our consumer. Questions? Okay, fine. And what do you do with the migration of the code that is not PSQL or like Java code? How do you transfer this? But we are Java developers ourselves, and all the Java code is something native to us. We have our own platform on Java, under Java, so we're trying to transfer to our platform. I don't really understand the question. So Java is referring based, but there is inbuilt support in Oracle of the function procedure under Java. That's right, but we do it simply. We just we take our platform, we restore the code, and then we bring back the result there. And the platform is at the same server hardware where the Postgres. Yes, we put the platform there. So it's a separate process. It's a separate process. That's right, yes. Initially, we had this concept that everything that Postgres can do by itself, we will do using Java, and Java itself that Postgres doesn't doesn't use. We're also doing it with our services. So we have the microservice architecture, so we are getting it all out there. And if Java code was supposed to put something into the user report, we rewrite it so to send it to the interface, not by database. PL Java extension, did you see it? Yeah, we saw it. It doesn't really work well, so we haven't phased the project where it's so much Java that we had to do that. So we just put everything into an application, always a way. Okay, I got it. Thank you. Any other questions? Good afternoon. Thank you for your talk. You had a slide of the examples, 125,000 lines in all these packages. So it's not that many for real Oracle. They had millions with the contexts, with autonomous transactions, with uninterrupted switches from one view to another, and a package that refers to itself, and other recursions, and the visa queries. So how does your migrator process context migration, like language constructions, structures? And it was a big problem when we migrated with because Oracle is very friendly to this kind of migrations, and Postgres doesn't really like it. It starts yelling that we can't do anything with these functions, so it's not a number, and figure it out yourselves. So, and all our structures, all this code, we had to replace them, or you were writing your own. Well, a lot of questions. I'm not sure if I remember all of them. Yes, it was just one project that we asked for permission to use in this talk, and there is a factory in Perm, so that's an actual software. So that's what they had exactly, and that's what you see at this slide here. As for the bigger numbers, well, of course, we have TBs of data in the packages here. The thing is that the consumers that have a lot of PSQL code, so they are very anxious about their code because we can migrate it, no problem about that. But they have their doubt that they will be able to check if we really migrated everything, because there is a certain percent of coverage. The bigger the code, the smaller the percentage is. So, and then we can say for sure, we can check that it works normally. But after we will migrate to Postgres, you won't be able to check it at all. So that's why we don't have a lot of projects like this. 10 million is the threshold after which and it says, so, well, I don't know, if we have 20 million lines of code, how can we check it afterwards if it was really transferred? So these are actual data, true data, but we are not afraid of challenges because mostly it is done automatically. And as for automatization, well, a lot is done manually. Yes, there are some problems, but have a tool to work with these, to find these problems. We have a tool that allows to connect to see what happened to a query, and we mark them, we tag them. If it was migrated automatically, it was done automatically, but something went wrong with this, and something that was done manually by developers. And it allows us to get inside all the necessary chunks of code and to adjust them, but there is no way to convert it automatically completely. So if there is a test scenario and we can check it somehow automatically, then it's good. And these projects are working really well. If there are millions of code and no one knows how it works, then it has its complications, its difficulties. Or the consumer will have to rewrite it and then to check how functions work in the enterprise and then throw out all that they don't need, or we just postpone such projects. Any other questions that I didn't answer from your one big question? One more question. The final code, is it really supported? Because there are a lot of details about smaller details that can really ruin the chance to develop the project further. If you have a task just to migrate, it's one thing, but a lot of projects are long-lasting and it's not over with the migration to Postgres. You need to continue developing such things as formatting and naming identifiers, to check tables and so on and so forth. Well, what we have that the person can read this code, our convert is not trimming the blanks or anything. That's the code that you can read and you can optimize. After our optimization, we think the code is readable, so we follow strict standards of formatting and in all our projects. So we support it, we maintain it, we suggest some of our colleagues to Pro have great online courses so they can teach you Postgres, and we teach our consumers how to read this code. And the general feeling is that after a month, those who worked with Oracle, they can use Postgres in the same way, so it's not causing any substantial problems. Yes, of course, they are not really liking that the number of tools Postgres is smaller than at Oracle, but they can still do the same. They can read it the same way they did it in Oracle. Yes, they face some peculiarities, like the type behavior, but still, that's the code that you can develop, that you can support, that you can maintain. And we recommend everyone to switch to Java and not to make calculations in stored procedures, but at services. So the client services that we worked with and the stored procedures, the modern services, Java and horizontal scaling, I'm just putting next to each other. Some examples for you, and it performs better. And it's not working like that with the database, because if you're putting two databases, then you're losing 30% of performance. If you synchronize three databases, then you're going to lose 60% performance. So multiple links applications to support them. So if you want to do this, then write all your logic in Java on C++, but do it in the memory, do it in the services, and then you are going to continue developing. It won't help if your calculations will come to a dead end, the network speed between Java and your database. No, it won't be a dead end. If you calculate everything on Java, everything will be working fine. And that database is just a storage. You're just taking data from there, you calculate them, and you get the result. And if you want to, you can save it at the database. So this approach, this architectural approach, that's what we suggest to do and to use. Any other questions? So let's thank Dmitry then. Thank you.